All right, everybody got there? Now, all I asked you to do was to write the electron dot formula for oxygen. I went ahead and gave you the orbital notation, the complete electron configuration, this new shorthand version of electron configurations, so you can see where we got all this. So if I go to orbital notation, I count the number of electrons that are in the highest primary energy level. 1, 2, 3, 4, 5, 6. And that's how many dots I put around there. 1 dot on each of the 4 sides, and I have to pair up 2 more to get to 6. If I go to orbital notation, then I just count the number of electrons that are the superscripts in this highest primary level, the highest primary level represented by the coefficients. So in the second primary level, I got 2 plus 4, or 6 dots. In the shorthand version, anything after the noble gas will be the number of electrons. Now you may have to drop out the D sublevels because those are down 1 sublevel. But in the second primary level, the primary energy level, we've got 2 plus 4 electrons. So I need 6 electrons around 6 electron dots. Does that make sense? So we're going to use this electron dot formula then for doing a lot of covalent bonding, figuring out how elements bond covalently. Now, does anybody remember from physical science what a covalent bond is? Well, you should know what a covalent bond is from physical science. It's the sharing of electrons. Okay? Covalent bonds share electrons. That's something you need to write down as a definition. Covalent bonds result from sharing of electrons between atoms. Covalent bonds result from sharing of electrons between atoms. Sharing of electrons between atoms. Now, the reason that atoms share electrons is to be more stable. And we talked about the D sublevel being more stable when it has a completely full set of electrons, and so it'll pull an electron out of the next highest sublevel. Remember that? Well, bonding occurs because atoms want to fill up all their orbitals for the same reason. They want to fill up all those orbitals because they're more stable that way. Okay? In order for bonding to happen, the orbital configuration has to change. Okay? So when we have an s orbital around any element, so this is oxygen, and here's the nucleus. The s orbitals form a sphere. Okay? And so this s orbital forms a sphere, and the 2s forms another sphere around it. But the p orbitals form some strange sort of shapes within this region. Okay? S orbitals are spheres, that's easy. That's like a ball, right? But p orbitals form some strange sort of shapes. Within this region here, the 2p orbitals are made of 2 parts. Okay? They have a kind of a mushroom head shape. So a p orbital is made of 2 sort of mushroom heads. So this is one p orbital. And here's the nucleus. Okay? A second p orbital will be located over here. Sort of mushroom head here. Alright? Now this is 2-dimensional, I'm drawing on the paper, but in 3 dimensions, the third mushroom head is coming out from the paper with another node behind it that you can't really see. I mean, we could draw it out here, but it starts to hide stuff. It would look like this looking at us like that. You wouldn't be able to see the nucleus anymore. Okay? That's hard to sort of imagine. So what we're going to do tomorrow is, instead of doing mushroom heads, we're going to replace the mushroom heads with balloons. So we're going to take 2 balloons and put them together like that to make a p orbital. Okay? But you need to remember that it's really only the top half of both of these that make up the orbital. There's no middle. Okay? But when we start putting the balloons together, we can see how the orbitals arrange themselves in space within this sublevel region. All right? And then hopefully tomorrow we'll get a chance to look at, well, let's see. No, I guess we don't do hybridization until the next unit. Okay? We'll look at how the p orbitals arrange themselves in space around the central atom. So what are you supposed to bring tomorrow?
Balloons.
What kind of balloons? How much? One package. One small package is fine. What kind of balloons and what kind of colors? Solid, bold, but different colors. So you need some greens and blues and yellows and things like that. But you don't want rainbow-colored balloons. You don't want one balloon that has red, blue, green, and so forth on it. Okay? Yes?
Are you going to talk about the corrections?
No, the corrections, if you're ready to turn them in, yes. But nobody came and got any help yesterday. I didn't know anybody was doing it.
Well, I found
Okay, if you got everything, that's fine. But the thing is,
not due today.
yeah, they're due today. But nobody came and got any help, so I didn't know anybody. I didn't really realize anybody was going to turn them in. So that's good. Sure.